So now let's look at some examples. So we're going to write these in scientific notation. I think we call this standard form. So to go to scientific notation, we need the number to be some number between 1 and 10. Well, that's always the decimal place going right here. So I'm going to take the significant numbers, the non-zero numbers, and write them out with the decimal between the 3 and the 2. And then I need to count out how many zeros are there here. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So in scientific notation, this would be 3.22146 times 10 to the 8th. The decimal place started here, and we counted this way this many times. Now, if you think about what's happening, this does mean multiplication. And so when we multiply this 3.22146 times 10 to the 8th, we're multiplying by, what is 10 to the 8th? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 1, 2, 3. We're multiplying by 100 million, so we should get that 322,146,000 back. All right, next one, here we have 238,900. So again, we're going to put the decimal place between the 2 and the 3. That gets us a number between 1 and 10. And notice we need 1, 2, 3, 4, 5 zeros, so 10 to the 5th. Okay, in terms of really tiny numbers, scientific notation is also useful, and we use negative exponents for that because that means division. So 10 to the negative 1 is really 1 divided by 10, which is 0.1. So negative exponents move the decimal place when we multiply by them to the right, whereas to the left, whereas positive exponents, when we multiply them, move the decimal place to the right. So here's an example. Here on page 84, number 7, the weight in grams of 1 grain of spruce pollen is 0.000017. Now notice we've got 1, 2, 3, 4, 5 zeros we have to get to our 7.0, our number between 1 and 10. So we're going to multiply this by 10 to the negative, how many did I say? 1, 2, 3, 4, 5. 10 to the negative 5. In other words, we're dividing by 10 to the 5th power. Okay, and then the last one, notice we need to just go 1, 2, 3 places to get this to be a number between 1 and 10. And so our result becomes 2.1605 times 10 to the negative 3rd. So now we're going to go back in the other direction. What if I give you a number in scientific notation, and I want you to write it out in decimal notation? Or standard notation is another way to call that. I think the book uses decimal notation. That's what Alex is going to use, so let's stick with that. Well, this means literally take 9.8085 and multiply it times 10,000. That's precisely what that scientific notation means. Well, if you recall what happens when you multiply by 10,000, that just means move the decimal place 4 places to the right. So we get 90850. We get 90,850. Likewise, when we take this 7.53 times 10 to the negative 10, that really means take 7.53 and divide by, and I don't want to multiply this out. I'll leave it as 10 to the 10th. Well, that means we're going to move this decimal place 10 places to the left. And the first one counts as one of them, so we need to include 9 zeros in front of whatever this number is. So 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 5, 3. That is our value for that. So in general, let's summarize this. When a number written in scientific notation has a positive exponent 10, what can we say for sure about that number? It's a large number. That is one way to state that. If a number between 0 and 1 is written in scientific notation, what can we say about the exponent on 10? If it's between 0 and 1, that guarantees it will be a negative exponent. It will be a large number, and it will be larger than 10. We can be more specific. Larger than 10. So if a number in some notation has a negative exponent on 10, to convert to decimal form, move the decimal place left, because the number is small. Example, 1.2 times 10 to the negative 3. That's 0.0012. Okay, one last thing we want to look at here before we do some crazy problems is what happens if you all are using your TI-84 calculators or a Casio or your cell phone, and you get some notation like this, 7.44 E3. Well, what this means, this is how calculators report scientific notation. This literally means 7.44 times 10 to the third. This stands for the exponent on a base 10 number. So it's a different form of scientific notation. And in decimal form, this would be 7440 or 7,440. I'm going to show you in Desmos in the next video how Desmos spits out these numbers.